Hi, folks. Welcome to another video in our Math 119 class, and we're talking about the different types of measurement scales, right? So let's take a look at this question. It says, what type of measure scale is being used? Nominal, ordinal, interval, or ratio? And so I want to remind us of two different types of data that we talked about earlier. We talked about quantitative and qualitative, all right? So let me just write those up there. Quantitative, that's the one that deals with numbers, okay? So when we are talking about quantitative data, we're talking about numbers. But if we're talking about qualitative, we are talking about categories, right? And the reason why those are important is because in this course, we're going to learn a lot of different words, and it's important that we can sort of connect them to words we already know instead of trying to learn new words that don't make sense in relation to anything else we know, okay? And so if I were to do a little bit of color coding here, all right, this quantitative type of data or something that looks at numbers, right? That actually corresponds to interval or ratio measure scales. And on the flip side, let's choose a different color. If we have qualitative data or categorical data, then we can measure that using nominal or ordinal measure scales. Okay, so now that we can kind of think about that, let's talk about the nominal and the ordinal first, and then we'll talk about the interval and the ratio. Okay. All right, so I'll make a little chart right here. We've got nominal. Wow, that's not how you spell it. Nominal, right? And we've got ordinal. And as I mentioned above, these two both talk about qualitative types of data, or they measure categories, okay? And so if we're thinking about nominal, it's just a category, all right? But if we're talking about ordinal, it's like a category, but with rankings, okay? And so that would be the key difference. We're looking at categories, but we're looking at categories that have rankings, okay? So let's actually go through and see if we can find in this list of A all the way through L, ones that we think are nominal or ordinal, so things that measure categories, and then which ones might be nominal and which ones might have a ranking or be ordinal, okay? All right. So high school soccer players classified by their athletic ability, superior, average, or above average. Well, that certainly is a category and it has rankings. So we're going to say that A is a qualitative measure, but because it has the rankings, A is going to be an ordinal measure scale. Okay. So let's get that all on one page so we can kind of see that. But I hope that makes sense that we're looking at something that measures categories. And then within those categories, if there's a ranking, we say that that's ordinal. Okay. All right. Baking temperatures. Well, those look like numbers, so that's not qualitative. The colors of crayons in a 24 crayon box. Sure, those definitely categories, but I mean, we might have our favorite colors, but at the end of the day, there's no scale that's like superior colors, average colors, right? So we're going to say that C, colors of crayons in a 24 crayon box, that is a nominal measure scale. All right, Social Security numbers. Well, let's see, those are numbers, but we don't actually do anything with them, okay? And so let's kind of save that for our quantitative measure one, okay? All right, income measured in dollars. Well, that's a number. F, a satisfaction survey of a social website by numbers. Very satisfied, somewhat satisfied, not satisfied. And that clearly has a ranking, so I'm going to put F underneath the ordinal one, okay? Maybe let's move that up a little bit. So Don't have to squeeze my writing so much. Okay. Political outlook. Extreme left, left of center, right of center, extreme right. Now, I know politics are sort of a tricky thing these days, but we may have things that we agree with and things that we disagree with, but at the end of the day, there's no ranking technically of which one's better than the other. Okay, so G, political outlook, it is a category. So we say that that's a nominal measure scale. Okay. All right, time of day, distance in miles, those all seem like numbers. Dates and heights, those seem like numbers. But common letter grades, A, B, C, D, F, I mean, I think that we can all agree that there is inherently a ranking system that goes into grades, right? Everybody wants the A. Nobody walks into a class saying, I want that F or I want that D, right? So I think here we have our 5 nominal and ordinal measures, which measure qualitative data points. Okay, so now let's go back through. We'll take a look at the quantitative ones, which should be the rest of them, but we want to make sure that they are measuring numbers, and we'll talk a little bit about the difference between interval or ratio. Okay. All right, break that up. We've got interval and ratio. And these are measures of numbers. Okay. All right. So the main difference between an interval and a ratio measure of scale is that an interval is more just numbers, okay? Numbers that don't really, I guess you could say, have a ranking, all right? But instead of calling it a ranking when we're talking about numbers, we actually call it a ratio. And what that means is that if you have like, for example, $20 is 2 times $10, that's a ratio, right? So when we're measuring money, that is a ratio measure of scale. But like if we think about dates like the year 1000 and the year 2000, the year 2000 isn't twice as big as the year 1000. It's just later in time, okay? And so something like that doesn't have a ratio, that would be considered an interval measure of scale. All right, so let's start at the bottom because we see to have that here. The heights of 21 through 65-year-old women, all right, those are numbers. And when we look at that, I mean, I think we can agree that if someone is 6 feet tall, they are twice as tall as someone who is 3 feet tall, right? So K would be considered a ratio measure scale. All right, the dates, 1066, 1492, 1644, 1947, and 1944, as I mentioned earlier, those are numbers. So those are quantitative, but 2000 is not twice as big as 1000, right? It's just later in time, some sort of arbitrary measure that we've picked, okay? All right, the distance in miles to the closest grocery store, well, that we can agree is quantitative, but that distance, like 2 miles, is twice as long as 1 mile. And so we can put that in the ratio column. All right, and let's keep moving up. We've got a time of day on an analog watch. So that's like when there are hands that go around. I think most of our watches are not like that anymore, but time of day in general, like 12 o'clock is not 2 times longer than 6 o'clock, right? It's just a later time in the day. And so that means that a time of day is an interval measure scale. All right, let's see what else we have. Incomes measured in dollars. When we're talking about income measured in dollars, I mean, if someone's going to offer you $500,000 in income versus $50, I think we would all choose the $500,000 because that's a lot more income. And so that has a ratio to it. So we can say that the income measured in dollars is a ratio measure scale. All right, Social Security numbers. What do we think about Social Security numbers? We've got numbers that sort of they definitely don't have a ratio, right? Like the bigger your Social Security number doesn't mean like the more important you are or anything like that. I think one could argue that Social Security numbers, could be classified as a interval measure scale. But I think other people might actually call it a nominal measure scale. So certain categories, they're sort of done by like the day and time that you're born, that's how your numbers, or you're sort of registered into the system, so that's how your numbers are generated. Okay, so I think this is kind of like the what was that example from the previous video, the one about the IQ scores, right? I think we could argue it a little bit both ways. But all right, let's take a look at the last one. Baking temperatures for various main dishes: 350, 400, 325, 250, 300. And I think we can see there that we've got a bunch of numbers, but again, like 200 degrees is not twice as hot as 100 degrees. And I know that's kind of weird to think about, but we can also think about it like 0 degrees doesn't mean there's no temperature, but with $0 means you have no money, right? 0 degrees in temperature is like, it's just a temperature, right? So there's no real ranking in that sense. Okay, so let me get this all on one screen for you, but I hope this color coding and sort of making sense of the information in a different way was useful. Try doing this when you're reading through the book. I know it can be kind of dense, but try thinking about how you can organize the information in your own way. Okay, let me know if you have any questions.